Hey there everyone, welcome to the series Automating the Boring Stuff in Ansys Mechanical. In today's video, we will be looking at inertial load where we will try to add acceleration and see what are the various properties available, what are read and write properties. Then we will try to add standard earth gravity as well. Let's get started. So to begin with, we will first try to get inside the mechanical. Let's say you are somewhere in the model, and to select mechanical analysis, the first analysis, let's assign it to variable a0, and it will be model dot analysis and the first index. So we know a0 is our analysis, and to activate we can just pass the method a0 dot activate. So it's a function which it does not return anything, and you will see our analysis has been selected. From here we will try to add an acceleration object, so it will be a0 dot add acceleration. It's a function and it returns an acceleration. Let's capture it into a variable acc so that we can use it for all our assignments. So acceleration has been added. Let's assign a name. It will be like my acceleration. Okay, so acceleration name has been changed, and let's see what are the things we have. Now this acceleration is applied to all the bodies, so you cannot change it. And then we have defined by property. Let's see what it is. It will be acc dot defined by. It's a getter set property, and the enum field name is load defined by. So let's see what we get. Right now it is defined by vector. If you want to change it, just press equal to and you will get this enum uh, name, and once you press tab you can assign whatever you need. So right now we will be looking at vector and components. So let's begin with vector. So in vector, what is there is you have a constant acceleration, but if you make it constant acceleration across a vector, and if you choose component, then you can pass like x, y, and z. So let's roll back to vector. First we will see vector and then we will come back to components. I have changed it to component, and let's see if we can add some magnitude. So acc dot magnitude, as you know, you cannot set through magnitude. It has to be an internal property known as input or output fields, and under that you have to get into a field name as a discrete value. We have already seen in previous video. So first let's get inside the input properties. So it will be acceleration dot magnitude dot inputs. So as you see, it is always list inside a list, and you have to capture the first index. So we will see that it is assigning 1 second. That's because it is constant in the second one. If you want a variable, then you have to set it as 1 and 2. So I already have this ready. Let's clear it out. So you will see that uh, okay, I think I did not cover that. So from here, what is happening is you are just getting the assigned time step. But if you want to assign something, then you will have to get into a discrete value property, which is get and set. You will get the same output, but yeah, here you can set or get. So here we will assign. So I have two timestamps, so it will be 1 and 2, and you will see that from constant it has become a variable, so it has become this one. So here you had constant, right? In constant you just have to pass for first second, so that's why you are getting first. But now once you change it to 1 and 2, it becomes tabular, and if you just try to get the discrete values, you will see instead of 0 is by default, that's why you are not getting here. But now since we explicitly pass this, so you are getting 0, 1 and 2. So similarly you have to assign the output, which is the acceleration for 0, 1 and 2. So I have that script ready, so you will notice. So this is the same thing. So instead of input we have output. Only for input we have to pass the first index, but for output you don't have to, because it is not list inside a list, but it's just a list. It's not a input is a nested list, but output is just a list. So here you will see that first is 0. In the second I will pass 10 millimeter per second square, and in second load step I will pass 20 millimeter per second square. So let's see. You will notice that it has been changed. Let's go and change the unit. So right now I am at so you will see 10 and 20, and if you don't make it to 1 and 2 second, if you just pass for first second, then it will be constant. Okay, now coming to direction. Direction is, as you see, it returns an object, but we don't know what it returns. So right now you see it is nothing has been assigned, but to assign direction you can select any edge. Okay, body will not be possible, so it has to be a vector. Like if I select this face, so what will happen is, you see this face direction is y and z are parallel and x is negative. So if I pass this, then you will get -100, because this plane is parallel to y and z plane, and but its normal direction is opposite to x, so that's why you are getting this. But what is the type of it? To get that, you can just pass direction dot get type. So we need to assign something, right? Let's say in automation, you don't want to select any phase, but you want to give a direction in terms of coordinates. So you will see this is a vector 3D. Vector 3D is a function. It's a function type. You don't have to import ansys.math. It's already available. So let's see how we can do that. So what I will do, I will create a vector, for example x vector, and I will create a vector 3D component. Okay, so vector 3D, it will be 1 comma 0, let's say y direction, so 0 comma 1 comma 0. So this is for uh, this this uh, this indicates a positive y direction vector. So it should not be, sorry, it should not be x, it should be y. Okay, and if I pass this y, you will see it is giving a vector 3D object. So here get type will be a vector 3D. So vector 3D, and it's pointing towards y direction. So we already had this acceleration, and from acceleration direction we will just tell you make it to y vector. Okay, and you will notice that acceleration has been changed to y direction, positive y direction. If you want it as negative y direction, so what you can do, you can just pass -1 here, and then I will pass this. You will see the acceleration has been reversed. So this way you can pass the acceleration direction. Now suppressed is to suppress, but we don't have anything. Let's get into component defined by. So it will be acc dot defined by and load defined by two components. So if you the previously what we saw in vector, we were passing acc dot magnitude dot inputs, right? But here it will be acc dot x component. So instead of just a magnitude, you have to pass now components, and then everything remains the same. For example, input 0, you will get 1 second, because you see in the second step they are equal to, it's showing equal to, that means it's constant. And to change it to variable, you just have to uh, pass 0, 1 and 2 second, and then you will see that for x direction it has become variable, but for others it's still the same, because you have to pass for each individual component. So let's assign some acceleration. So acceleration is same thing, but instead of that magnitude, you have to pass x component, and here acceleration is the same that we used in magnitude, and you will see it has become 10 and 20. Similarly, you can do for y and z. Here you don't have to pass any direction, because we already have the components x, y, z here. So I already have for x and y. I'll just paste it here, and you will see that for y component, for each component you have to pass the input. You just if you want it to be variable, or else you can just pass the output value just for one load step, and you will see that it is quantity 1 2, and then similarly instead of 10, let me pass 30 and 40, and here let me pass 50 and 60 for z direction. Okay, and if I execute, you will notice that, let me expand this, you will notice that xy direction has been set. So this was all about acceleration. Let's go back, let's see what else is there. You will see the standard earth gravity as well. So I already had the analysis object, right? Standard earth gravity, I will just put sg, and then it will be a0 dot add earth gravity, add earth gravity. Okay, so earth gravity value is fixed, we don't change it, but we can change the direction. So it will, the only variable, I mean, which we have to use is global coordinate. Also you can change, but Right now let's focus on the direction. So it will be sg dot direction, and you will notice it is giving negative z axis, and it was a its enum name is gravity orientation type. So if you just press direction and equal to, you will see the enum name is coming, and then once you click dot, you will get all the field values. So right now it is z direction. Let's make it minus negative y, and if I execute, you will see that earth gravity has been applied. So this was about the inertial load, and in next video we'll be looking at all the different kind of supports. Thank you for watching the video. If you liked it, please subscribe and hit thumbs up. Thank you.